All right, so here we are. We're going to do Chapter 6 and the first bit of Chapter 7. If anybody wants to do a presentation today, you get extra points for doing it early. Next week will be a time to do your presentation normally. And that's the second presentation. And there's not much left of this class. As you can see, we're down to 7 and 8. That's the end. 7 and 8 are the last modules. And then there's just a final exam coming up, and I have no new material for the last class. Some people want to do presentations today. Good, good. Sounds good. I will make a note. Rouhani. And 9 Gnosis. You probably need to give me a better name than that to give you your points, but it'll probably come up during your talk. All right, good. Melissa, all right. Good. All right. Anyway, let me go through these chapters from the book, and then we'll do presentations from people who want to do it early. It's very good of you to do it early. Get it out of the way, get some extra points. That's fine. Yeah, and if you're going to be at RSA instead of here, that's fine. There'll be nothing but student presentations next week, so you won't miss any lecture. All right, so security assessment and testing. Go to the start of this. Somehow I'm in the middle. All right. So access control is, of course, the systems that limit who can do what on your network. So one thing you do to test it is penetration testing. This is where you pay white hat hackers to hack into your system and then tell you what flaws they found and give recommendations how to patch them. So they might test your internet. They might be coming on the phone networks, the board dialing, or the wireless network, or physically picking locks and getting into secure rooms. Social engineering is the most common form of attack. The most common way pen testers get in, and also bad guys, is phishing, which is social engineering, sending you an email and tricking you into clicking on a link. Black box test is where the attacker does not provide any information. They just have to try and find it on themselves. A full knowledge test gives them information about your diagram and procedures and such, and you can have one in between. These are different kinds of tests you can perform. So Metasploit is the open source tool which lets you perform many attacks in a nice framework and organize the results you find from those attacks. Immunity Canvas and Core Impact are the expensive closed source tools that are more advanced and often include zero-day attacks, for which there is no patch. So here's the steps of pen testing. You plan how you're going to do it. You do reconnaissance, trying to learn about the company or the network from open source or other sources. Then you scan devices to find out what services are offered and try to enumerate what accounts and files and folders are available. Then you often run a vulnerability scanner, find vulnerabilities, then you exploit them to get in and accomplish your goal, and then, all important, you issue a report to the company explaining what you did, what you found, and what recommendations you have for them to improve their security. This is what the company is really paying for, is that report, and it's very important that your report is convincing and polite and clear, so that it helps convince a company to improve their security. So the pen testers have to keep the stuff they find confidential, of course. They're finding security flaws on a network, and that's not public information. And the report is also not public information for the same reason. Now, there's vulnerability scanning, which is a much simpler activity than a pen test, where you just run an automated product like Nessus, and it runs through a long library of network traffic that tests for various known flaws, and it finds out which ones of them you're vulnerable to. These scanners very often report vulnerabilities that are not real. They mistake traffic, and so if you want to be sure the vulnerability is really there, you have to manually verify it. And then you have to consider what the real threat is on your network, because the scanner will report a SQL injection if it sends up an apostrophe and sees an error message, but that might have no important business significance. It might be some unimportant database that has public information. It doesn't matter. So the scanner cannot really evaluate how dangerous what it finds is. It requires a human that understands the business. A security audit is another important test. This is where you check to make sure you meet a certain standard, like PCI DSS or SOC 2 or some other standard. You just have you check to make sure that a whole bunch of security things are being done, and that's how you prove that you do meet that standard. Then there's security assessments that will check your controls at many levels. They might do administrative things and policies, change management, or other tests. There's many ways, parts of security you can be assessing. You can have internal audits, which you should have, where you test internally to see if your company is obeying your own security policy. And then you have external audits. You either pay for this because you want to be more secure, or you're required to do it in order for compliance. If you have PCI DSS because you take credit card payments, if you take more than a certain number of credit card payments, you are required to have an external audit every year by a special auditor who will come check. So, log reviews are one simple way to do it. There's a lot of logs on your system, and you can see if your access control mechanisms are working. You can see your remote access software log to see if people are coming in your network that shouldn't be there, and routers and firewalls, your operating system events, and your application logs all measure what's happening, and you can look at that and see if people are coming in and doing things they shouldn't be doing. One thing you really have to do is a high privilege audit to see what your administrators are doing, because they typically have the ability to do almost anything, and if they start doing bad things, they can also cover their tracks. So auditing what administrators do is very important. Having a centralized point of logging is essential. If you just let every device put a log locally on the system, then it's very hard to go through those and find things. So you typically move that data over the network to a central repository that keeps it. syslog is an early Unix-based system that sends log data over UDP 5.14, and there are many other later products like Splunk and Splunk agents that will harvest log entries from various devices and send it to a central location. Then you can retain the logs for whatever period of time is required. Your regulatory or legal requirements might require you to keep logs for a certain period of time. So to test your software, you're trying to find the errors that your programmers have made. If you've written custom apps inside your company, then it's real expensive. Not only do you have to write them yourself, but you have to update them. And so there isn't anybody else to find security patches. You'll have to write your own patches if you write your own apps. So I remember when I worked in a financial company, I started writing code, and the boss told me, don't write code, figure out how to do it with the existing features of Microsoft Office, because he didn't want to incur this debt of having custom code that would have to be maintained by the company. So you can review the source code. There's two general approaches. As I mentioned in the news section, there's static and dynamic analysis. Static analysis looks at the source code without running it to look for patterns of source code that indicate security flaws. And dynamic analysis checks the running application, sending data in the way users would, to see if you can find data which, when sent up, provokes unusual responses. Then there's manual code review. Pair programming is another technique often used, so two programmers work together on the code, so hopefully they will make fewer mistakes as two eyes have examined the code as you're writing it. So that's static testing, and there's programs like Lint that will do this, looking for known bad code in the source code. Then dynamic testing while it's executing. You can have white box testing where the tester has source code, or black box testing where the tester does not have any internal details and just has to deduce things from the inputs and outputs. All right, you can map your customer requirements to your software testing plan. They call that a traceability matrix. And you can make synthetic transactions, so you have a pre-canned series of actions to simulate what customers do, and you run through that to make sure that your web app is meeting its requirements. So unit testing tests components individually to make sure each component is working correctly. Installation testing checks to make sure that freshly installed software is working. And then integration testing makes sure that your software components are working together correctly. Regression testing is testing software after an update, modification, or patch. You have changed something, so now you run your standard test to make sure you didn't break anything important. Then acceptance testing just makes sure that the software meets your customer's requirements and may be done by the customer, called user acceptance testing. Fuzzing is a type of black box testing where you send random data up to the server. You often start with legitimate requests, and then you modify it by making longer text fields or changing values or putting in random bit flips. And the point is you're trying to find unexpected behavior. Typically, you crash the app, and then you may be able to control that crash and develop exploits, and that's what we're doing in the exploit development class. This turned out to be extremely important, and almost every company now does fuzz testing before they release hardware or software. It's highly irresponsible not to do that. You find a lot of flaws this way. Here's a note here. The TSMC breach was because the patches for Windows machines hadn't been applied. Yeah, because they were the intersect. Okay, I didn't know TSMC got breached. But yeah, that's a common thing. People often don't put on Windows patches because they tend to break things, and that makes them vulnerable. And often they think since they're not directly connected to the internet, they'd be safer, and they would be safer, but not completely safe. Anyway, then there's combinatorial testing. This tries to find all unique combinations of software input. You can also call it pairwise testing, where you have pairs of inputs. And then there's misuse case testing, where you try to model an adversary. This is quite a big deal these days, adversary emulation. There's a bunch of products to do this, to try to imitate a whole attacker going through all the steps so you can test to see if your defenses will pick it up. And threat modeling is another term here, where you try to imagine what kind of people would attack you and how they would attack you, and then see if you can defend against it. And Microsoft has a security development life cycle and a STRIDE model to guide you to the types of threats that will come in. And so test coverage measures to what extent you have tested your application. For example, if you test an application in use, you will find that you probably are only hitting like 10 or 20% of the code. Much of the code is for exceptional situations that don't come up. So that's an issue. You often do not really test the whole app. That's why you often find serious security flaws in strange little corners of the app that are almost never used, like old hardware that's almost never used, reset and password reset functions, things like that. Strange little code on the side that isn't tested much is more likely to have big flaws. All right, and so then you get your tests. It's easy to run a test and get results, but actually improving security is much more difficult. As I mentioned with pen testing, if you run some kind of scanner, it gives you a report with a bunch of flaws, but getting someone to actually fix the code requires the difficult step of analyzing it and then convincing them to actually put in the effort to fix the flaws. And that requires working with the developers and the management and guiding them into believing they can fix things and helping them make reasonable steps forward. It's difficult. Many people would rather just ignore the problem. All right, so let's try a Kahoot. That was 6. Oh, yeah. That was 2018, the TSMC breach, yeah. I think I did hear about that. It's just a while ago. All right. Kahoot.it, Ronnie. All right, good. That may be it. I'll wait a few more seconds. All right. Okay, how do you ensure HIPAA compliance? A security audit, where you compare your things inside your company to the requirements. All right, what process runs on UDP 514? Yeah, that's centralized logging, Linux syslog. All right, what process happens after you update software? That's regression testing to make sure that things still work correctly after a change. All right, and what does Microsoft highlight in their software development system? Software development lifecycle, they call it. It's threat modeling is their big thing with the STRIDE model. All right. All right. And the third one's got to be Rouhani. It is. That's good. All right.